Well, welcome to lesson 5 of this Arduino C++ course, and today we're going to be looking at digital pins again, except this time instead of having outputs to LEDs, today we're going to be reading from buttons. We're also going to be looking at the need for pull-down resistors and later on how to debounce a button. So let's have a quick look at what's on the breadboard. So at the end of lesson 4, we had the flashing red LEDs and also the green LED flashing. Obviously, they were flashing independent of each other. Today, we're going to be moving down to this part of the breadboard, and we're going to be looking at buttons. Now, on my breadboard, I have got this type of button. They have 4 feet to them, and there is sort of 2 hooks. The hooks sort of go either side of the breadboard. You may in other kits have these smaller buttons. You can see the top of one here, they just have the 2 legs. In that case, when you are placing them on the breadboard, just place them on one side of the breadboard. You don't need to worry about going over the center sort of barrier. Now, as always, there's a link below the video to the Digital Town website where you can click on lessons.php and get all the information to do with this tutorial. So going over to the website, just scroll down to lesson 5. As always, there is the circuit diagram, and that's the bit that we're going to look at again first. So here we have that circuit diagram. It's exactly the same as in the previous lesson. So let's just have a look at what is going on within the circuit. So with the buttons, it looks a little bit strange at first. You have the 2 pins on the button, depending which type of pin you have. Obviously, if you've got those 4-pin buttons, you're just using 2 pins on one side, the other are over here. You'll see that you have a connection that comes from the digital pin on the Arduino, and it goes into this row of pins, but within this row of pins there is also this resistor that goes between this row of pins and ground. Now, the reason for this is that we want our signal to be very clear, 0 or 5 volts. So if we form this connection with this resistor to ground, the circuit will go straight to ground, so we will get a very good 0 volts through this resistor. Now, on the other side of the button, there is a connection to 5 volts. So when the button is pressed, we now get 5 volts comes across here through the button and will go straight on to the pin, giving a really clear signal. And I'm going to give you a demonstration later as to what happens if you do not have this pull-down resistor. Now, the pull-down resistors, the usual values are either 4.5k or 10k ohms. So that is 10,000 ohms or 4,500 ohms, just to make sure you get the right type of resistor. Now, one other thing just before we leave this diagram, obviously I am using buttons here, and in the previous tutorial we were using LEDs. Now, the LED is just an output from the Arduino. This LED could have been replaced by a relay or some other device that just needs to be turned on and off. We're just using the LEDs for demonstration purposes. In the same way, the buttons that we have here could be replaced by a sensor. We could put a PIR sensor in there, an infrared sensor. Most of the time with those sensors you will not require the pull down resistor, and I'll probably use some in a later project to show you how they work. But the actual method of reading from the sensor is the same as reading from the button, just so that you're aware of that for your own projects. So a new lesson, a new sketch. So it's been called Lesson 5. As before, all of the pins on the circuit are listed, and I've already done a little bit of work. I have created a variable bright blue LED. I've then created a variable, these are integers, and these are called, if you like, left button and right button, because when I look at my breadboard, I have a left and right button. Keep these things basic. Then we're starting the serial monitor, and just as in the last lesson for the LED, we're setting the pin as an output. You notice as I put my cursor over output, it gives a reading there, a hex value of 0x1. For the buttons, we are reading information from the button, therefore they are both being set as inputs. And you can see if I put my cursor over that input, that gives a value of 0x0. So we're going to use the word input, but we could just put a 0 in there if we wanted. Next, we've got another integer. Now you'll notice these integers are declared up here in the top of the sketch. This integer is being declared in the loop. Now there is a difference between declaring the integer here and here. If an integer or any variable is declared in this part of the sketch, you can use this value, this variable, anywhere within your sketch. As you can see, I can use it in the setup, and I'm also going to use it within the loop. However, if a variable is defined within a function, in this case the function is the loop, this variable is only available within the loop. Now there are some oddities with this, because if I have a variable here that has a value, I can change that value in any function that I want. The difference with this variable, so these are called, if you like, a local variable, whereas these are called a global variable. A local variable is created at the start of the loop. The code runs to the bottom of the loop, and then this variable is destroyed as the code exits the loop. Now obviously as it comes back round the loop, it recreates the variable again. Now this means that every time the loop starts, in my case, the variable is reset to a value of 0. So a local variable in a function does not keep any values that are put into it. Every time it starts again, it gets destroyed. So that's the difference between a global variable and a local variable. Now coming down to our next line, if you remember in the last sketch we used to use digitalWrite to send some information to a pin. This time we are using digitalRead. So let's have a look at the reference and see what it says. Now this is a very easy function to use. If we just click on the function in the list, all we do is we give it the value of the pin that we wish to read from. That's all that we need to do, and it will return, as it says here, high or low. Now high is a 1, low is a 0. So going back to our code, we have created our variable, if you like, the box that we're going to store our information in. That box is then filled with the output from this digitalRead. So the 0 or the 1 value will be stored in this variable, and then we're simply going to serial print this out to the screen just by printing the value of button press. So the code is uploaded, and as you can see on the serial monitor, I have a nice set of zeros. If I now press the button, it goes high and that value goes to 1, release the value, goes to 0. And you notice it's a really crisp on and off. Now, while we're looking at this, I am going to pull out the pull down resistor. Now, at first, you would sort of think, well, nothing's happening. What's different? There were zeros before, there are zeros now. Now, watch this. As I put my hand near to the various wires and start to press the button, it hasn't gone back to 0. As I put my hand back, notice the buttons fluttering on and off, and this is partly due to the capacitance of my body that is actually causing an issue with the circuit. Now, this is a very simple circuit, but if we had far more items and more wires and connections and different signals going by, it would cause even more issues with this particular button. So the pull down resistor basically acts as an anchor to stop that flutter that you can see on the screen. Otherwise, we're never going to know if our button is being pressed or not. Now, just as a reminder, on my screen, you can see that I've got the time going by. The reason I tend to have the clock on, and it can be turned on and off using this symbol. But if I turn the clock off, all I've got is a line of zeros. I don't know if that's actually moving or if it is stationary. So turning the clock on helps me to see that these are a constant stream of data coming through. If you want to stop the flow of data, you can click on the auto scroll and it will just freeze the data, but obviously data is still being read to the serial monitor. And if you want to get rid of the information in the serial monitor, you can just clear the output. But of course, in this case, it's going to refill instantly. So now we understand that we're getting a 0 or a 1. Let's use that to control our LED. And we can do that very simply. We can just use an if statement. So we can say if button press, and again, I'm a copy and paster, is greater than 0, and then we're going to need an else statement. So if that value is greater than 0, we are going to digital write, and we're going to just copy and paste from up here. We can digital write the blue LED, and we're going to send it high. And then the alternative is we can send it low. So let's compile that and see what happens. So now reaching over to press the button, you see the 1 in the serial monitor, and at the same time the blue LED comes on. As I take my finger off the button, it goes off. Success! Now I've reused the if statement, but we could write this code in an even faster way. So let's just copy this and paste it down here. And what I'm going to do now is comment that out. And instead of putting low, I'm going to put the value of button press. If you remember, when the button is pressed, we get a value of 1, and high is equal to 1. When the button is not pressed, we get a 0, and low is 0. So now if I upload this code, And once again, bring up the serial monitor. There we go. Exactly the same results, but a few less lines of code. Now, the reason for showing you that other method is just to show you that sometimes there is more than one way to do something. And it doesn't mean that this way is right and this way is wrong. Each is suitable for different situations, and sometimes it just comes down to personal preference. Sometimes you may have a bit of code that you just get used to doing something in a particular way and just stick to that way because you know that it's going to work. So just be aware there are different ways to do the same thing. It's not right, it's not wrong, it's just different. Now, whichever your preference, I still have a problem with either bits of code. So button on, button off. If I want to keep that LED on, I've got to keep my finger on this particular type of button. Now, I could switch the button to, if you like, a toggle switch, but if I'm just going to use a toggle switch, I might as well get rid of the Arduino and just wire up the LED with a switch. What I would really like is to press the button and for the LED to stay on and then be able to turn the LED off separately. So that's what we're going to work towards next. So I've commented out the first example. I'm going to leave it in the sketch so that if you want to download the code off the Digital Town site, you can just see it's all there and just uncomment it. We're now going to use what I would call two-button control. Now we've got exactly the same line as we had in the first example. We've then got the serial print, just as in the first example, and I've also got half of the if statement. I just haven't used the else. So all we're going to do at this point is if the button is pressed, it's going to turn the LED on. Now I've already uploaded the code. So if I now press the button, the LED comes on and I can take my finger away from the button and it remains on. Now all we need to do is turn the LED off. So to turn the LED off, we're going to use an almost identical piece of code. So this time, button press, so it's the same variable. We've used the variable in this bit of code. We can now reuse it because we don't need the old value. So now button press is doing a digital read of the right hand button. I'm still serial printing out the value. And then if button press is greater than 0, so if the right hand button is pressed, instead of sending the pin high, we're going to send the pin low. So let's get that uploaded and see how it works. So now I can press that left hand button, LED comes on, wait as long as I want, press the right hand button and the LED turns off. We have success. Now, although this code is now working and I can happily be turning my LED on and off with my two buttons, I would prefer to be able to press one button to turn the LED on and then press it again to turn it off. So to do that, we have to go back to some code that we used in the last lesson. So this is lesson 4, the code that we used in the previous lesson. And if you remember, in the last lesson, we were using a state for the LEDs. And depending on the time, we were changing the state of the LED to turn it on and off. What I'm now going to do is use a similar system where when the button is pressed, it changes the state instead of using time to change the state. So that way we can press the button and change the state in one direction, press the button again and change the state in the opposite direction. So going back to our sketch, just like in lesson 4, I have created a variable, just a byte, because it's only storing a 0 or a 1, and I've called that the right blue LED state. Now coming down to the main loop, I've commented out all of the other code. So we've started on example 3, and just as before, button press is going to be the digital read of the left button. If that value is greater than 0, so if that condition is met, it will then run the second if statement. This is called a nested if statement, and sometimes you will find that you finish up writing if statements within if statements within if statements. That's when you need to really keep your eye on this little line to make sure that you've got the right number of curly braces in your code. So just like in the previous lesson, instead of using time, this time it is if the button is pressed, let's use the if statement here. If the blue LED state is greater than 0, set it to 0, otherwise set it to 1, and then whatever the value it has been set to, let's set our LED to that value. So let's get that code uploaded. So now as I press the button, oh, that doesn't work as well as it should. Hang on. It's not working properly. Sometimes it is working, sometimes it's not. What on earth is going on? Now, you will run across situations like this where you start to think, what on earth is happening? So what we're going to do, we're going to put in some debugging code. And all we're going to do is we're going to serial print line, and the value that we're going to print out is the LED state, just to see what is going on. So let's upload the code. I'm going to clear the output, because in our code, this is only going to trigger when a button has been pressed. So as I press the button, we should just see a 0 or a 1. Let's press that button. Ouch! Look at that. How many 0s and 1s have we got? Let's clear the output, and I'm going to try and press that button really quick. That's about as fast as I can go, and there must be 70, 80 lines of 0s and 1s. Now, to start to understand the issue, the answer is actually in front of us on the serial monitor. Now, I am outputting the time on the serial monitor. So at the moment, we have the hours, the minutes, the seconds, and then the thousandths of a second. Now, what I want you to notice is that from here down to here, all of that has taken place within the same, if you like, millisecond. And the issue that is happening here is to do with the speed that our Arduino is running. Going back to the diagram that I've often used to explain how the Arduino works, if we think about our main loop, if there's nothing in the main loop, then it will go round this main loop every sort of 3 or 4 millionths of a second. Now, the time that it takes to do a digital read is approximately 4 microseconds, not milliseconds, microseconds. Now, to put that in perspective, a microsecond, 4 microseconds is 0.0000004 of a second. A human eye, when it blinks, is 0.1 of a second. Now, what you have to realize is, as I'm pressing this button, in the time that it's taking me to press the button, going back to our loop, the loop has gone round and it's actually reading the button press over and over again, because my finger is on the button for such a long time by computer standards that it's just reading on, off, on, off, on, off constantly. So we need to figure out a way to slow down the read time of the button so that the Arduino will slow itself down to speeds that mere humans can use. So the technique that we're going to use is called button debouncing. Now, it doesn't just deal with the problem with my finger, if you like, being on the button for a long period of time, but if you can imagine, as I press the button, don't forget how fast the Arduino is looking at that button. As I press the button, I might not sort of press it fully down, it might sort of bounce up and down a little bit, so make contact, break contact, make contact, break contact. Don't forget this is happening in millionths of a second, so this little bit of code will also get rid of, if you like, that electrical bounce as the button is pressed. So what I have now done is I have commented out that last version that we had our problem with the bouncing buttons, and I've made a duplicate, and we're going to look at this as example 4. Now, to do this, I've needed to create some new variables, and you're going to smile if you've done the previous tutorials, because guess who's back in town? Yes, it's current millis. We're also going to use button millis as the timer for the buttons, and we're going to set a debounce time of 350 milliseconds. Now, the debounce time will be the amount of time my finger can be on the button before the button is read again. Now, this is always an interesting figure. If you make the number too small, if you went down to say 150, 200, the chances are that you will get double presses because your finger will be on the button too long. If you make this number too big, it can make the system feel sluggish. Now, with our demonstration, because I'm only using 2 buttons, I could set this at 500, even up to 1000 for 1 second, and it wouldn't be a problem. But if you were using, say, a touch screen like an LCD screen, then it's better to have a number that is a bit lower. And from my experience and with the age of my fingers, I tend to settle at about 350. So that's how this value is chosen. Anyway, as before, so that I don't misspell anything, let's copy that, bring it all the way down, and I'm going to paste it in here and comment it out. Now, as before, at the beginning of the main loop, we still have button press, and now we will start to write our new bits of code. So, as before, current millis equals millis. We know what we're doing there. Then we are going to go if current millis minus button millis, let's copy that one, is greater or equal to button debounce time. Then, and only then, will we run this bit of code. Let's just click the auto format to set it all out nicely. Now, when I was doing the LED timer, if you remember, we had a line that came in here that went button millis equals current millis. Now, you can use that system for the button debounce. The way that would work is obviously it's only going to check the button every 0.35 of a second. Now, for a project like this, 0.35 of a second would make no difference at all. However, if you want the button to always register the exact moment it is pressed, literally down to the microsecond, rather than putting this line here, it gets changed and it gets put in here. Let's just move that out and put that up there. Now, the reason for that is if you think about the loop of code, current millis minus button millis will be greater than or equal to the button debounce time. So that means, if you like, at this moment, the button is ready to be read. Now, if we read the button and we get a 0, the button is not being pressed, so we don't need to start the debounce timer at that point. We can literally wait until the button is physically pressed, and only at that point do we then reset the timer. So if you like, it's 350 milliseconds from the point the button is pressed, whereas in our previous sketches, when we were using the current millis as a timer, it was always the time from when the last item occurred. So if you like, the difference between a timer and a debounce is just to do with when button millis is reset. So I've uploaded the code, I've reset the serial monitor, and let's start pressing buttons. On, off, on, off. Looking good. Obviously, if I keep my finger on permanently, it will flash, but realistically, if I'm just doing on, off, as long as I do that press in less than 0.35 of a second, all will be well. Now, to finish today's lesson, I'm going to add one more item in. And this is to do with the right button. So we're going to get the right button to do something while the left button is also working. So you can see how two buttons work and how we would debounce them both. Now, to do this, going back up, I have created some new variables. I'm going to create two new variables to do with pins. We're going to use the left yellow LED and the right yellow LED, which means we also need a state to store their state in. So that's going to be yellow LED state. Coming down to the setup, obviously pin mode, that should be left yellow, shouldn't it? Let's get my comments correct. And the other one correct. This is the trouble with copying and pasting stuff. So that's done. And then coming down to the main loop, again, I've still left button press at the top. But now coming down to example 4, before the code ended here, all I've then done is put the second button press in. Notice the second button press is within the if statement for the debounce. Now, the other odd thing about this, It's very similar to the flashing code for the red LEDs. So what I'm going to do with the yellow LEDs is when the button is pressed, one LED is going to turn on, the other LED is going to turn off, and obviously when it's pressed again, that's going to reverse. But I just want you to notice that the first, if you like, when we're doing the left button, there is a reset of the timer if the left button is pressed, and that line is repeated if the right button is pressed. So if you like, the debounce is always reset whichever button is pressed, but both buttons are using the same debounce timer. You could create it so that each individual button had its own timer. You're welcome to do that, but for a project of this size, using one debounce timer will be enough. So let's get this code uploaded. So that's all loaded up. If I press the left button, we still have the blue LED going on and off. Now though, if I press the right hand button, I can alternate the LEDs while still being able to control the blue LED. Now going back to the webcam, just some things to bear in mind. Obviously we have used buttons and we've used LEDs. These could be swapped out for relays. These could be infrared sensors, PIR sensors, all sorts of different digital sensors could be used instead of these buttons. So this code that we are using, that we're developing for this, if you like, very simple LED and button technique, can be used in a variety of projects. So I'm going to end today's lesson here, and I hope that's been helpful. Please have an experiment. If you've got some more buttons, don't forget on our circuit diagram, we still have one pin that is not used on the diagram. So you could always add an extra button in there and control another set of LEDs. Have a bit of a mess around and just enjoy yourself with the Arduino. Now, these lessons are making some progress. We're going to be looking at some of the analog inputs, but if you have any particular items that you would like covered, please just go to the Digital Town website, and at the bottom of the lessons page is an email address. Just send me a message of any particular project and I'll see if I can include it in the later lessons. Anyway, hope that's been useful, and I'll see you in the next one. Bye for now.